The next water balance example contains different units of parameters from both the metric and English systems. Welcome to hydrology. The problem includes a watershed of 2,000 hectares area. A 10-day storm has been recorded with the following properties, and we are tasked to compute for the change in soil moisture and also the final soil water storage. Checking on the record, we use the water budget equation of inflow less outflow is equal to the change in water storage. We start by categorizing each parameter, such as precipitation under inflow, evapotranspiration, average stream flow, irrigation input, and groundwater recharge all are under outflow. Then the change in soil moisture lies under change in water storage. The last input in the table, which is initial soil water storage, is not a part of the equation. This parameter shows the current moisture of the soil prior to the storm. Replacing the parameters with their respective values, the water budget equation becomes the change of soil moisture is equal to 27.2 inches minus 4.8 centimeters less 0.15 hectare meters minus 2.7 cubic feet per second less 2.6 centimeters. With a different unit for each term, we can't simplify the equation yet. So in order to simplify values, convert units into centimeters, as required in the problem. The first term is 27.2 inches, which would be multiplied by the conversion of 2.54 centimeters to an inch, which makes the first parameter equal to 69.088 centimeters. The second parameter is kept as it is because it is already in centimeters. Next is 0.15 hectare meters. Eliminate hectares by dividing the term with the catchment area, thus canceling hectares. Then meters need to be converted into centimeters, so use the conversion of 100 centimeters is to a meter. So 0.15 times 100 divided by 2,000 is 0.0075 cm. The next term to convert is 2.7 cubic feet per second. First is to take out seconds, and that is done by multiplying 3,600 seconds per hour and 24 hours per day. Then to cancel day, multiply the duration of 10 days. This takes out the time from the parameter. Next is cubic feet. We're multiplying the square of 3.28 feet per meter, then 10,000 square meters for a hectare can meet the unit for the catchment area, which is 200 hectares. At this point, the remaining unit is feet. So multiply the conversion of 3.28 feet per meter and 100 centimeters per meter. Place the unit into cm. Finally, multiply values 2.7, 3,600, 24, 10, and 100. Then divide the result by the square of 3.28 with 10,000, 2,000, and 3.28 to get 0.3305 centimeters. The last term from the equation is 2.6 cm, which is taken as it is. So, the change in soil moisture is 69.088 cm less 4.8, 0.0075, 0.3305, and 2.6 centimeters, which results to 61.35 cm. The next requirement is the final soil water storage, which is solved as the initial soil water storage plus or minus the change in soil moisture. The initial soil water storage is given in the problem as 0.08 acre-feet, and delta storage is solved earlier as 61.35 cm. We are to convert acre-feet into cm first before taking the summation. So multiply the conversion factor of 43,560 square feet is to 1 acre. Then a meter is to 3.28 feet. And also a hectare is equivalent to 10,000 square meters. This will transform acres into hectares. Then divide the term by the catchment area of 2,000 hectares. And this takes out the unit. The remaining unit is feet, which needs to be converted into cm by multiplying 3.28 feet per meter, and 100 centimeters is to a meter. Multiply and divide values from the converted term and have 0.000494 cm. With both terms in cm, we then add 0.000494 and 61.35, which provides 61.3505 centimeters.